This lesson is about how to assess potential risks in a product FMEA and plan measures to minimize these risks. And hello again to this lesson, which essentially has two learning objectives. At the end, you should be able to carry out a risk assessment. Among other things, you will learn how to rank the severity of failures and the probability to detect them, or the occurrence. You should further be able to define appropriate prevention and detection methods to further minimize risks. This lesson is divided into two chapters. In the first chapter, we assess the potential failures based on an example from the previous lesson. In the second chapter, a risk assessment is carried out and methods are discussed with which the risk can be further reduced. Let's start with the assessment of the potential failures for functions and characteristics. However, before we get to the FMEA form to make the assessment, let's briefly state where we are in the FMEA creation process. The creation of an FMEA is divided into 7 steps. Firstly, the planning and preparation, during which, among other things, the scope and limits are determined. Secondly, the structural analysis, followed by the functional and failure analysis. In this example, these steps have already been carried out as part of a previous lesson. This lesson is about steps 5 and 6, with the risk analysis and the optimization with the status of the different actions. At the end comes the risk and results documentation. What you see here is the FMEA form from the previous lesson for a seatbelt buckle. The knowledge required to create and understand an FMEA up to this point is assumed here. In order to keep the FMEA simple, the last 2 system elements have been removed. We will therefore only carry out a risk assessment for the 2 system elements of the buckle and the bracket. To do this, we will look at the individual failures step by step, assess them and fill in the empty columns C, S, D, O, RPN and AP. Let's start with the column S. S stands for severity of a failure and refers to the failure effect or consequence. The consequences resulting from the fact that a failure occurs are therefore assessed. Examples of possible outcomes or consequences would be that people could be injured or laws could be violated. Less drastic, but still very serious, the main function of a product could no longer be given, or there could be significant process disruption. Something like customer irritation and complaints can also be the results, to name just a few examples of the possible consequences. On a scale of 1 to 10, the severity of the impact of a failure is ranked. 1 is for failures that are practically insignificant and go unnoticed by the customer. 10, on the other hand, is for failures which, when they occur, endanger the life of people or their physical well-being or violate laws. Especially when such failures can also occur suddenly and without warning. In between, there are further gradations, some of which are listed here in extract. 9 would be used, for example, if serious safety deficiencies or functional impairments occur, possibly breaking the law. Failures that occur gradually or with advance notice, but are below the severity level 10. 8 would be a security flaw, a major customer annoyance or loss of primary function. A failure could be ranked with a 3 if the customer would only slightly be annoyed or only minor visual or noise impairments were the consequence. It would be a 2 if the customer was hardly touched or if there were hardly any noticeable visual or acoustic impairments. If we now look at the failure effect, driver dies in the crash and legal requirement not met in the FMEA, then the severity of these failures must be ranked with a 10. Consequently, the same assessment must also apply to the next consequences of failures. The driver is not held in the seat and is injured, and the braking load is less than 20 kN. On the other hand, the last failure effect, minor rattling in the vehicle, is only to be rated with a 3 according to the catalogue on the right for the severity of a failure. A further classification results also from the assessment of the severity, as we will see next. As we have just seen, there are characteristics and functions with very special importance. Such special characteristics must be marked as such in all documents in which reference is made to them. To do this, these characteristics or functions are marked with the CC or SC. However, there may be also other customer requirements here. CC stands for critical characteristic. Failures that could cause death or injury or violations of the law are such critical failures and are marked with CC. Significant failures or characteristics that are marked with an SC, these are still characteristics and functions of special importance but below the CC category. This would be, for example, an inoperable but safe product, or when the customer would be very dissatisfied. Such failures may occur gradually or with advance notice. SC characteristics should be identified by a consensus of the FMEA team as well as the customer and supplier. Classified functions or characteristics must be identified as such throughout drawings, the control plan, the work and test instructions, and the like. Now we come to the probability of occurrence. Probability of occurrence is about evaluating how likely it is that a cause will result in a failure. So it's about the estimated number of failures per cause. In order to prevent the occurrence of a failure, suitable preventive methods must be established. The preventive measures established at the time of the assessment must be documented in the FMEA. The assessment of the occurrence is based on the ability of the preventive actions to avoid errors. Two examples of established preventive methods would be process capability that has already been proven or other historical data. In the left FMEA, the already established preventive actions were entered for the cause rivet length too long, therefore rivet head too small. A process capability for the rivet length greater than 1.67 has already been demonstrated. As you may already know, process capability is a percentage of process results that do not meet the required specification. This amount is usually in the range of a few parts per 1 million parts manufactured. Here I recommend the lessons on process capabilities. As with the severity of a failure, there is also a catalog for the occurrence probability and for the detection, which ranks the different probabilities on a scale from 1 to 10. A failure that occurs almost constantly is rated with a 10. In numbers, that would be more than 31,600 defects per 1 million produced parts. A failure that is extremely unlikely to occur, for example a failure that is completely unknown from history is only rated with a 1. The other gradations in between are shown here only in part. Please check the criteria according to which you have to carry out the assessment. Based on the criteria shown here, in column A of the FMEA form, the probability of occurrence of the various causes was rated from 1 to 3. So, next are the detection probabilities. Probability of detection is about assessing how likely it is that a failure will be detected. In order to ensure that a failure is detected, suitable detection methods must be established. The detection methods established at the time of the assessment must be documented in the FMEA. The assessment of probability of detection is based on their effectiveness in detecting errors. 2 examples of detection methods would be an automated 100% check as the most effective methods versus a random sampling as a less effective method. 2 detection methods were entered in the FMEA form. A braking load that is too low can be detected by random braking load tests. An incorrect riveting length is detected by a 100% fully automated measurement. As with the severity of failures and the probability of their occurrence, there is also a catalog for the detection of failures. Here, the probability of detection is also ranked from 1 to 10. A failure that cannot be detected will reach the customer with a high degree of certainty. If the probability P that a failure will be discovered is less than 10%, the probability of detection should be given a 10. At the other end of the scale, the probability of detecting a failure can be increased to almost 100% if, for example, 100% automatic testing is in place. Then the detection probability is to be rated as 1. The other possible rankings in between are only shown here in part. Please check the criteria according to which you must make the assessment. Based on the criteria shown here, the detection probabilities of the various failures were rated from 1 to 3 in column E of the FMEA. This concludes this chapter and we move on to the next. Now let's move on to the prioritization of the failures and the measures to reduce them. One way of quantifying risk that has been established for many decades is with the help of the risk priority number, short RPN. It can be used to classify potential system or design flaws. The risk priority number is formed from the product for the ratings of the severity, the detection, and the occurrence. A high risk priority number means high risk. A maximum of 1000 points are possible. If S, D, and O were each rated 10, then the product of 10 times 10 times 10 is 1000. The smallest possible number is therefore logically 1. As can be seen in the table, the risk priority numbers were calculated for the various functions and characteristics and entered in the FMEA form in the RPN column. The next step would then be to further reduce the risk priority number through appropriate actions. Of course, the question immediately arises as to how far this must be reduced. There is no clear answer to that. Sometimes there are specifications that do not allow RPN above 100 or 125. But sometimes it is just required that the risk priority number should be reduced as much as possible and makes economically sense. But there is another way of quantifying the risk. We will get into that now. The action priority is a rating method introduced in the AIAG and VDA Failure Mode and Effects Analysis Handbook. The AP provides a priority level based on severity, occurrence, and detection values. For the action priority, the rating of severity, detection, and occurrence is the same as previously determined for the risk priority number. The action priority sets the priorities using a traffic light system. There are 3 risk matrices. One for the combination of severity and occurrence, one for the combination of severity and detection, and the third for the combination of detection and occurrence. If you end up in a green field in one of the combinations, the priority is low. If you end up in a red field, the action priority is high. Yellow is, of course, in between. With the 3 different action priorities, green, yellow, and red, for each of the combinations S and O, S and D, D and O, there are a total of 27 different task priority combinations. These are sorted according to their priority in a so-called risk matrix ranking. The risk matrix rank goes from 1 to 27. 1 has the lowest priority, 27 has the highest priority. The risk matrix rank also has 3 task priorities: low, medium, and high, color-coded green, yellow, and red. The highest priority from one of the 3 combinations S and O, S and D, and D and O determines the color for the risk matrix rank. This form contains the first status of actions taken in 2021. Taking these statuses of measures into account, the evaluations resulted in a risk priority number of 500 each. By establishing better prevention measures and more effective detection methods, the rating in both categories could be further reduced. This made it possible to reduce the risk priority number from 500 to 60 and 20. Not explicitly mentioned here, but a person responsible for the status of the actions must be named and an implementation date must be planned. An FMEA is a living document. It should be checked regularly to ensure that it is up to date, and new findings should be incorporated into the FMEA. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the 4 most important key messages. The severity, the probability of occurrence, and the probability of detection of a failure should be evaluated using criteria that are as objective as possible. A ranking in the form of a risk priority number, RPN, or risk matrix rank, AP, is used to classify system or design deficiencies. Reasonable actions must be taken to further reduce the design deficiencies. And the FMEA must be kept up to date. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care, and see you next time. Bye.